A few decades ago, I would not have believed that when walking in the forest, I would be carrying with me a dynamic map. A map that not only displayed the terrain, but also revealed in real time my location in the landscape. As you know, this is now reality, and the inventions that make this possible, the Blackberries, iPads, and other wireless devices we carry with us, represent an incredible evolution in wireless technology. Most of us never wonder about how this stuff works, we just use it. So in this video I will attempt to explain some of the basic science behind wireless communication and show you how to construct a very simple wireless transmitter. Let's start with a quick look at wired communication. In this system of communication, metal wires, often mounted on poles, are used to carry electrical signals from one town to another. This technology evolved rapidly in the 19th century. You can often see the remains of these early communication systems running along beside railway tracks. The process was simple. A switch, called a key, was used to control the flow of electricity on the line. Samuel Morse proposed a code of dots and dashes, short and long pulses of electricity, to represent letters and numbers. This, of course, is Morse code. The dots and dashes were detected at the receiving end either as an audible signal or as marks on a paper tape. Telegraph keys were much more sophisticated than my simple example, and key operators were capable of sending and receiving code at very high rates. Many amateur radio groups still have members capable of transmitting and receiving Morse code. Systems like this that use Morse code are called telegraph communication systems, and during the latter part of the 19th century, a worldwide network of cables appeared, including the first transatlantic cable, a communications cable joining Newfoundland to Ireland. The next step in the evolution of communication occurred in 1876 when Alexander Graham Bell was granted a patent for the telephone. It was now possible to carry voice on wire cables. The next leap in the evolution of communication occurred with the discovery of electromagnetic radiation, a discovery that made wireless communication possible. If you've been studying electricity, you will know that electricity is a flow of charged particles, usually electrons. If you connect a conductor from the negative to the positive terminal of a battery cell, electrons will start to flow. This is electricity, electrons flowing from minus to plus. It turns out that starting and stopping this electron flow creates pulses of radiant energy. These are electromagnetic waves. In the latter half of the 19th century, German scientist Heinrich Hertz successfully detected these waves. Further investigation revealed that these waves are part of a spectrum of energy that includes visible light. The full spectrum of energy represented by this electromagnetic radiation spans everything from extremely high-frequency gamma rays and X-rays to very low-frequency radio waves. Visible light is in the center of the spectrum. All electromagnetic radiation travels at the speed of light. Let's investigate low-frequency electromagnetic radiation. You can create and detect electromagnetic radiation with this equipment: a AA 1.5 volt battery, 2 meters of insulated small gauge wire, a 15 ohm resistor, and an AM radio. Make sure the radio is set to AM, not FM. Here's how you do this. Create the antenna by connecting the resistor to one end of the wire. This resistor can have any value between 15 and 25 ohms. I used a 15 ohm resistor soldered and taped to the end of the wire. The purpose of the resistor is to reduce the current flow so the wire and battery will not overheat. Without the resistor, you could create a short circuit. Tune the AM radio to a quiet spot. That is, you're not tuned to a radio station. Sit the radio close by with the volume turned up, then tap the ends of the wire to the terminals of the battery. Connecting and disconnecting the circuit, you will hear a static pulse on the AM radio. You have detected electromagnetic radiation. There are some safety considerations here. Only use one AA 1.5 volt battery for this demonstration. To avoid short-circuiting the AA battery, you must use a resistor in this circuit, and never experiment with anything plugged into a wall outlet. Now that we have created and detected electromagnetic radiation, let's communicate with it. One of the earliest and most dramatic uses of wireless communication occurred at midnight on April the 14th, 1912, when a call for help radiated from the sinking Titanic. The wireless transmitter on the Titanic was designed by Marconi. It used high voltage and high current. The massive antenna array consisted of 4 150-meter cables suspended high above the deck. A rotating disc with conductive bumps on it was used to make and break the circuit at a high rate, transmitting a low-frequency buzz when the key was pressed. The operator used the key to control current flow to the disc, transmitting the dots and dashes of Morse code. We can duplicate the effect of a rotary spark gap transmitter with a linear row of contacts. You will need a strip of aluminum foil, a block of wood, and some nails. The dimensions aren't critical. Looks like this when completed. The end nail provides a connection terminal for the battery. I've placed the battery in a holder, making connections easier. Again, only use an AA 1.5 volt battery. Connecting one end of the battery to the antenna, we are ready to transmit. Again, tune an AM radio to a blank spot on the dial and turn up the volume. Sliding the available antenna wire along the row of nails creates a buzz on the radio. As the wire moves across the nails, the circuit is alternately completed, then broken, each contact sending a pulse of electromagnetic radiation. SOS was a universal distress call transmitted using Morse code. This is what SOS sounds like from our transmitter. Three quick contacts produce a Morse S. 3 long contacts, an O. A message similar to this one radiated from the sinking Titanic, alerting the Carpathia. This ship arrived in time to save over 700 people. The electromagnetic radiation that Hertz discovered in 1886 carried this distress call from the Titanic. And 100 years later, it is carrying the data that is creating the map on my smartphone. The sophistication of the technology enabling these modern digital devices is incredible. But at the very root of this sophistication is a process not unlike Morse code. The simple off and on, the zeros and ones of the binary number system, the process that enables all digital devices. If you're interested in learning more about wireless technology, there are a number of clubs and organizations dedicated to amateur radio and wireless communication. Groups like the Radio Amateurs of Canada, the Radio Society of Great Britain, and the American Radio Relay League host events and provide education related to wireless technology. You may have a club in your community. For more science and technology related videos, visit our website, hylaroad.com. Follow the project's link.